Welcome back, everyone. Uh, in this video, we are going to look at the definition of sine and cosine, where they come from, and also equation of unit circle. We are also going to look at how to find the exact values of uh, sine theta or cos theta or tan theta. So let's get started. So first of all, think of a unit, think of an unit circle. So as drawn in the diagram, maybe I'll just draw it again so that we can understand as we go. So think of it this way. If we have everywhere we have one, so one, and one, that's where the unit circle comes from. And then you have that unit circle, and think of a particular point, doesn't matter where, anywhere. Let's call that P. Now, if you go a certain distance to the x, so that's your x coordinate, and then if you go a certain distance y, that's your y coordinate. So in other words, in a Cartesian coordinate plane, you will have x and y. So this is your x and this is your y, and that's the location of your P. And this is, as we called it, unit circle. This must be 1. The length must be 1. And if it forms a theta at the center, we are saying, look at this. If you know your cos theta and sin theta already, so think of that as, okay, let's do cos theta first. Okay, so if we write cos theta, what are we going to write? Cos theta should be adjacent by hypotenuse. That's right. So it should be cos theta. Similarly, if we write sin theta, what should I get? Y opposite over hypotenuse, which is sin theta. So in other words, you can see this P at any point is really cos theta and sin theta. All right. So that's the definition of unit circle. From that, interestingly, there is another way to get to it, but maybe I'll just do it now. So think of this as Pythagoras theorem. If you recall, we can say x squared plus y squared should be equal to 1 for the right angle triangle. In the same way, we could say cos squared theta plus sin squared theta is equals to 1. We always did cos squared theta sin squared theta equals to 1, but now you know where it comes from. So this is where it comes from. Let's get to the next topic at hand. So the next topic is maybe something familiar. You must have done it already, but if you haven't done anything related to radians, that's okay. We are going to cover it from the very beginning, how radian is being defined, and then we go from there. So we all know a circumference of a circle is given by 2 pi r, and now we'll understand the definition of radian. So 1 radian, and radian is a measure of angle. So there are angles that you can measure in either radians or in degrees. Like, for example, you can measure your velocity or speed in kilometer per hour or meter per second. Depends on what you need. So similar to that, you can do in radians or you can do in degrees. But we already know we have 360-degree around the dot or in a circle, and that 360-degree is the same thing as 2 pi. So 360-degree is the same thing as 2 pi. So in other words, pi is equals to 180 degrees. So pi is in radians. So we'll understand what radian is in a sec, but just understand the conversion now. So radian equals to 180 degrees. So if we say 1 rad, it should be 180 over pi. But if we say 1 degree, it should be pi over 180 degrees. So so that's the equivalence. You should always remember pi equal 180 degree, and then whatever the conversion you need, just use that to convert them. Now coming back to the main point, which is what is radian. As you can recall, c equals to 2 pi r. That's the circumference. And we are saying if the circumference of the circle, if we make an angle that is the arc length is equal to the radius, the angle that forms at the center is 1 rad. So that's the definition of 1 radians. So if you make a sector such that your arc length, in other words, this is your arc length, is the same as your radius, you have 1 radians. So how many radians should you have in a circle? Because the circumference is 2 pi r. If you divide that by r, you have 2 pi. So that's the other way of getting to how many radians in a circle, which is 2 pi. That's where it comes from. Now we need to memorize few things. Let me tell you where they come from. The best thing is to just understand them and then memorize it for to save time in an exam situation or whatever the case. But if you can't memorize it, but there is a technique to remember it and to get it quickly, but I tell you that takes time all the time. But in terms of doing it in a test environment, the best idea is to just memorize it quickly so that you save time, because the exam is really time, let's say 3 hours or 1.5 hours, and if you just spend a minute to find out a certain values of some angle, uh, you can save a lot of time. Okay, let's get to how we can get the numbers, and then if you prefer to memorize it, memorize it. If you prefer to use this technique to find the numbers, go for it. It's all up to you, but I suggest you memorize this 9, or not really 9, 15 different things, but it's all up to you. I'll just try to explain to you where it comes from. Firstly, pick a right angle triangle with unit length, so 1 and 1, so these are equal. So what does that mean? The other should be 45 degrees. This should be 45 degrees. This should be 45 degrees. And what should the third side be? We can use Pythagoras. So 1 squared plus 1 squared should be 2. So clearly, using this triangle, we can find out cos 45. We can find out sine 45 easily. What would that be? 1 over square root of 2, 1 over square root of 2. Simple. So that's 45 out of the way. Next, we could use another form of triangle, which is equilateral triangle with 3 equal sides of 2, and we can divide in the middle. That gives us 1 and 1 here, but the interesting thing is this is 30, because equilateral all are 60. So if you divide in the middle, it becomes 30 and 30. So what do we have as the uh, perpendicular bisector? This must be square root of 3 using Pythagoras. 2 squared minus 1 square root is square root of 3. Now we can use this set of triangles to find out cos 30 and cos 60. Similarly, we can find sine 30 and sine 60. So we are done with 30, we are done with 45, we are done with 60. So what's left is 0 and 90 degrees, because we are interested in 0, 30, 45, 60, and 90 degrees. So if we look at this whole range, this is done, that's done, that's done, we're done, left with this and left with that. So that too can come from the sine sketching. So if you already know, sine looks like something like that. So that's a 0, that's a 2 pi, in other words 360 degree. This is 180 degree, this is 90 degree. So as you can easily see, sine 0 is 0, sine 90 is 1. So sine is taken care of. How do you do cos? Cos is nothing but move this graph or shift it to 90 degree to the left, and you have your cos. So cos would be something like this. Cos would be something like that. So cos 0 should be 1 and cos 90 should be 0. And that covers your 0 and 90 for cos. Now if you may ask, how do we find tan? You can use the triangle to find tan, or you can use tan theta equals to sine theta over cos theta. And you already know sine theta, you already know cos theta, so you can find all the angles related to tan as well. Or you can also use these two triangles to get your 30, 45, and 60, and 0 and 90. You can apply the formula and get it. Now there's one more thing, which is once you get all of this out of the way, you should make a table like that with 0 degree, 30 degree, 60 degree, 45 degree, and 90 degree. These are theta. So this is cos theta, this is sine theta, this is tan theta, and then write all the numbers here and put it on the side. Try to memorize it if you can. If you cannot, just put it on the side and use it whenever you need. Now one last thing on this, which is how to convert this to radians. You already know, so you can do the conversion, but I'll just quickly give you. This is 0 radian, this is pi on 6, this is pi on 3, this is pi on 4, this is pi on 2. So you can do the conversions yourself and match it, but you also need to quickly understand what is 30 in radians, what is 60 in radians, what is 45 in radians, what is 90 in radians quickly. And then we use this table to find out exact values of different numbers. But in order to do that, we also need an extra information regarding the quadrants. So I'll do an example. So if you already know, that's good. If you don't know, that's fine. So this is called first quadrant, this is called second quadrant, this is third, this is fourth. So this is labeled as all stations to central, or all students take chemistry. However you want to, however way you want to remember it, it's up to you. What does that mean? This means all. All means sine, tan, cos, all positive. This is only sine positive, this is only tan positive, this is only cos positive. So these are the quadrants where these particular theta are positive. In other words, sine is positive at the second, tan is positive at the third, cos is positive at the fourth, but at the first quadrant, everything else is positive. Now, when it comes to problems like this, for example, question A, look at that. It's sine pi by pi, pi 5 over 6. So straight away you might not know in which quadrant it lies, but what you can do is convert it quickly to degrees and then you understand where it lies. So the way to do it is pi into 180 divided by 6. So that's 150. So what I did is pi into 180 divided by 6, which is 150 degrees. And 150 degrees clearly is in the second quadrant. It's here, somewhere here. And remember, all stations to central. So this is sine. So if we are looking for sine, this should be positive. So we already know the exact values of 0, 30, 45, 60, and 90, but we don't know the exact value of 150. What can we do? We improvise. In other words, we try to write it in a way so that we can find the exact value. In other words, we write sine 150 as the same as sine 180 minus theta, or well, this theta is really 30 degree. So what does that give you? Sine 180 minus theta. But where does sine 180 minus theta lie? Sine 180 minus theta is here. That means in the second quadrant, which means it's the same thing as sine theta or sine 30. In other words, what's the value of sine 30? Half. Sine 30 is half. So simply sine pi by 6 is half. That's how you can find the exact value of any other angles except the ones that you already know. So you gotta tweak it a bit so that you can get to what you need. So maybe I can just go through another example. For example, cos 2 pi on 3, what should we do? 2 pi on 3 is 180 and back, which is same as pi on 3. So it's better you convert them, then you can see it better. So 2 into 180 divided by 3, which is 120 degree. So where does 120 degree lie? 120 degree lie here. But how much from here? 60 degree. Because if this is 120, this must be 60. So what does that mean? Cos 120 minus 60. But remember, this is sine. All stations to central. So cos is negative there, cos is not positive. So it must be minus cos 60. Now we already know cos 60. So we can get the value of cos 60. And then we can simply put minus in front of cos. So that way it should be negative value for cos. But if we wanted to find sine, sine should still be positive. So if we say sine 180 minus 60, which should give you still sine 60, which is positive. So that's all from me for this concept. I hope it made sense. You can continue doing these problems and see where you get at. I think there is another concept here which we'll be looking into a separate video, because this has already been 19 minutes. I don't want to make this video any longer. So good luck everyone with finding out exact values. Go through the MathSpace examples. Try to do it yourself. See if you can. If you cannot, watch the video again. And if you still have further questions, send me a message on WeChat. I'll see you guys in the next video.